In your eyes, you have photoreceptors that line the back of your eye or retina that detect light. A special kind called cones are particularly sensitive to red, green, and blue wavelengths of light, the same color of light shining through your phone right now. Just from these three, we can get an additive effect to make any colors of the rainbow. People who are colorblind have non-functional or abnormal cones, which means the specific cone affected cannot transmit the light energy into electrical impulse to be registered. The most common is red-green color blindness, affecting 8% of the male population. 5% of these men have deuteranomaly, which is the reduced sensitivity to green light caused by an abnormal green cone. They can't tell the difference between violet and blue, and traffic lights to them are always going to look red.
So let's dive into the genetics of why this happens. Color blindness is a sex-linked recessive trait on X chromosome. Since women have two X's and men only have one, their extra X gene can mask a handicap, whereas in men it's not possible, leaving more men colorblind. If you are a female and you marry a colorblind man, then none of your children will be colorblind, but about 100% of your daughters will carry the defective gene. Let's say your daughter now marries a non-colorblind man. There is a 50% chance their son will be colorblind and their daughter will be a carrier. If a colorblind man has children with a woman who is carrier, then both daughters and sons have a 50% chance of being colorblind.
But it's not all dire for people with color blindness. There could be a cure, and it's a viral infection. Dr. Jay Nates and his team of scientists working madly in their labs at the University of Washington wanted to see if it was actually possible to cure color blindness using gene therapy. The theory was that maybe we could give back the missing photopigment gene to make the cone work again, but no one really knows how the brain would respond to this foreign gene. So what they did, they adopted two adult male squirrel monkeys named Dalton and Sam. What's interesting is that in humans, 1 in 12 males are colorblind, but for squirrel monkeys, all males are red-green colorblind. Talk about being dealt a bad hand.
Why is this the case? Remember, males only have one X chromosome. Well, in male squirrel monkeys, the XX chromosome can only hold one copy of the red or green opposite gene, which means they will always have dichromatic color vision. Okay, so in Dr. Nate's experiment, he and his team trained Dalton and Sam to play a color test game. They had a green screen which could flash different patches of colored dots covering the rainbow, and if Dalton and Sam touched all the color patches they could see, they will get a grape juice.
Once Dalton and Sam got the hang of it, it's time to play the real game. This is where the trippy bit comes in. To give back the missing red opsin gene, they first took a human red opsin gene and transfected it into a virus. But why use a virus? Viruses have this special ability to inject their DNA into foreign cells. So Dr. Nates was thinking we could use the virus as a vector into a human genome. So with this, scientists injected the virus holding the human red opsin gene into the retinal photoreceptor layer.
Just 20 weeks after this treatment, Dr. Nates and his team reported on 16th September 2009 in Nature that it worked. Dalton and Sam could see all the colors, topping a record high score. This also means that the adult nervous system was capable of adapting to the introduction of a foreign gene with a new sensory input. Some scientists said that this is due to neuroplasticity, the ability of the brain to rewire its connections, whereas other scientists have said that it's Dalton and Sam's visual circuitry already capable of accommodating that extra red opposite gene. If it works on squirrel monkeys, maybe it will work with humans, and that's exactly the direction Dr. Nates is taking this project, with his first test subjects being patients with Leber congenital amaurosis. These people are born with impaired retina and slowly lose their vision in life.
If this works out, who knows what other possibilities are out there?
Created using Powtoon.